works. Great. Okay. Welcome, everybody. And I'm going to talk about today about using cloud-init in CloudStack. But first, you always have to, of course, the introduction. Who am I and what am I doing here? Well, thank you, Simon, for actually introducing me this morning, for being the oldest PMC member present here at the conference. So, born in '86 in the Netherlands, live in the Netherlands, married now, and father of 2 sons. And actually, I figured out, at the last CloudStack conference, I didn't have any kids. And then COVID came along, and now I've got 2 kids. So, I always call myself a nerd in a suit. I started as a techie guy. Nowadays, I work more in management positions and do a lot of Excel, spreadsheets, PowerPoints, and all that kind of stuff. But still, I like to CLI, working on the CLI, and I'm still a techie, doing a lot of techie stuff. I started my own hosting company in 2004. I think somewhere around 2011, we found this project called Cloud.com, which was then donated to Citrix and became CloudStack. And ever since, I've been using CloudStack, developed a lot of features for CloudStack. So I'm an open source enthusiast, IPv6, Ceph, CloudStack, those are the things which I work with. And you can find many of my presentations going about IPv6, about Ceph, VXLAN, all that kind of stuff, how that works in CloudStack. But today we're going to talk about cloud-init. And this seems like a very simple tool, but for a lot of people it's magic. Suddenly their VM works, SSH keys are in their VM. But how do they get in the VM? How does it work? How do you actually get the data in your VM? So, but before we start talking about cloud-init, a bit of my work now. I work at a company called Cloud Infra, Cloud-in. This is not a company you're going to be finding where you can get your services from. It's part of a company called Total Web Hosting Solutions, which is a buy and build strategy in the European Union. We have companies in Netherlands, Spain, and France, and Cloud Infra builds the internal infrastructure for this hosting company. We host a couple of million websites in Europe, all hosted on Apache CloudStack, or going to be moving towards Apache CloudStack. So we have data centers running in Amsterdam, in Valencia in Spain, and around Paris as well, where we have Apache CloudStack running and we're deploying our services on. Or the companies which we have acquired will be moving towards CloudStack at some point. This takes time, sometimes takes years to actually do the migrations, but that's what we're doing. So it's a buy and build strategy from a investor perspective, but we're going to be talking about technology here, not about investors. So we start deploying VMs on a cloud platform. And what I see people doing? They build a template for everything. So they have a template with direct admin, the control panel pre-installed, because they need the template. And they build one with WordPress pre-installed, with MariaDB, etc., etc., etc. They keep building templates to actually achieve what they want to achieve, to get a specific application installed on the cloud. But that brings some challenges. So you're going to be having an Ubuntu template with your personal SSH key in there already because you want that SSH key in there. But you're going to have a bunch of Alma Linux templates with one with MariaDB installed, well, with the web server, and these all have a bunch of SSH keys pre-configured because, that's what you did. And probably, how did you get the template? Well, you installed the VM manually using an ISO and then clicked Create Template from disk, and then you have a template, and we keep using the template. But we now have one for Ubuntu, for Debian, for other distributions, for Windows, etc., etc., etc. But you have to maintain all these templates. So you have this old template, which still has this security leak in there, maybe even Heartbleed from years ago, still in the template. But hey, it works, right? We keep using that template. But then you copy the template again to get a new version. Well, you get my point. You keep growing and growing with templates. But what if we could separate the operating system, the template, from the actual functionality the VM needs to run at a later stage? Well, that's where cloud-init comes in. So cloud-init, this is just a copy from the cloud-init website. It's that, cloud-init are operating systems, and every instance starts out identical as the other one, but then we feed in some information, and suddenly becomes a unique virtual machine running its purposes. So cloud-init is used to configure the locale, the host name, SSH keys, some mount points if you like. You can do a lot of things with cloud-init. But then the question is, how does this data get into the VM? How would you need to build a template with cloud-init in there and actually use it? So I created this fairly simple diagram. We have something called user data, and there's metadata as well, but let's call it the user data. We have a template, we merge it together, and we get a running VM. So the VM in the end will run your service, but it all starts as the same template. This template could be a plain Ubuntu, plain Alma Linux, or whatever distribution you prefer. I'm a Linux guy, I don't know much about Windows, so don't start asking me questions about cloud-init or Windows, please, because I don't know. But this is how you get to a VM, and the VM could be a web server, a database server, or some other application which you want to run on the cloud environment. Now, what can cloud-init do for you? It can simply set the host name, it can add SSH keys, it can execute a script for you in first boot, format a data disk, run an Ansible playbook, install packages, whatever you prefer, cloud-init can do it for you. And this seems very trivial, but it's a very powerful tool to actually deploy a lot of virtual machines very quickly, and all get them automated and get them up and running. Because so when we acquire companies, I start telling people, well, we want to scale out. If I ask you for a web server today, you might say, yeah, sure, I can install a web server. It takes you a day to install a web server. That's kind of pointless. If I ask you, I want to have 1,000 web servers by tomorrow, that should not be a challenge. If you're going to say, well, that's a lot of work, installing 1,000 web servers, well, then you need to start thinking about automation. Because 1,000 or maybe 10,000, well, kind of depends on how fast your cloud is deploying, right? But that's the whole purpose, that it makes it very easy to deploy applications on your cloud environment. So, well, why should you use this? Well, I think I already gave a lot of reasons, but it's separating concerns. So there's the operating system template, which has the basic functionality needed on your cloud environment. So think about the template. It has cloud-init pre-installed. If you're running with KVM, it has the QEMU guest agent pre-installed. You probably disabled swap files on the VM. You might have pre-configured a few things already in the template, but just the bare minimum to get the template up and running and have it a secure template for your VM. And yeah, it's fully integrated into CloudStack. It's the industry standard. So if you're going to be working with AWS, with DigitalOcean, with Vultr, anybody else, they all support Userdata, which you can provide to your VM and then get the VM up and running. So it becomes like cloud agnostic. The same data can be used on all the other cloud environments to deploy a nearly identical VM. So there's these two things called Userdata and metadata, which go to the VM. So the Userdata is provided by the user, hence the name Userdata, and the metadata comes from the cloud platform. So in this case, CloudStack, in our case, generates these and configure them inside the VM. But with the Userdata, you can... Very important. If you do not provide that line, cloud-init will... Okay, that first line. So there's also the ConfigDrive, which is a virtual CD-ROM. I'll talk about that a bit later. But from my perspective, what I see is that the network one, talking to the VR, is the most commonly used in CloudStack. So there's a data source, a Python file in cloud-init, which does this. So it's fairly simple what it does. It looks at the DHCP, IPv4 lease, and it will try to contact the DHCP server and actually connect there. So this is a bit of the Python code where there's a functionality called getDataServer, which is a function in Python. Well, it gets an address, and then it opens or tries to open the lease file, tries a lot of things to actually find the virtual router or a data source to fetch the data from. And when it works, it simply connects via HTTP to download the files. And on the virtual router, you go to var www.html, and you'll find a directory called metadata, called userdata, latest, and an htaccess file. And the htaccess file, it redirects internally based on the IPv4 address of the VM. So that's the unique identifier which is being used by the virtual router to serve you the right data. So there's no authentication. It's all based on the IPv4 address of the virtual machine, which is contacting the virtual router to download the data. And then if I would go to a directory of this particular VM, to start with, only this VM can download the information, because based on the IP address, the directory, you're either allowed to download or you're not allowed to download. So only the VM can download it. And, well, the user data being served to this VM says, hey, cloud config, well, example VM, a time zone, and then a SSH key being injected into the VM. So this is the user data which is ready to be served to the VM whenever the VM requests it. So if you then start looking at the log file of cloud-init inside a VM, you can see that it does a lot of things But mainly this part, found server address, and this again, this is a different network where I tested, via network D leases. In this case, the VM is using systemd network D, so cloud-init asked systemd network D, hey, what's the DHCP v4 server in this network? It found it, and then you see that it starts downloading all the HTTPs from the virtual router and obtaining the data it needs. But this, of course, means that the template you have built needs to have cloud-init pre-installed inside the template. So also referring back to the previous talk, the SSHDs do not work out of the box. You need to make sure that the template you use has cloud-init pre-configured with the CloudStack data source and a few settings, so you make sure it works. But then you'll see this, that CloudStack actually downloads it. And there you also see this line, seeing any data from the data source CloudStack, which is being used, but that's because we pre-configured that data source. But there's also a password reset. So you know this button in the UI where you hit password reset and you get a password, and suddenly the password of your VM changes. Is that magic? Nope. No, it isn't. It's also being done by cloud-init. So the template has the feature password enabled yes or no. This is how you signal CloudStack that this template is actually being able to actually reset a password. But this works by the management server generating a password and then providing in the API response, this is going to be the new password of the VM. And then when the VM boots, this password is being sent to the VR. And there's something called the password server running inside the virtual router, which then serves that password to the VM if needed. So if there's a password on the password server, then cloud-init will reset the password of the virtual machine, and that's it. However, the VR will forget the password as soon as it's downloaded. So this also means that the password is stored on the VR, the VM boots, it fetches the password, and it resets the password. But if you then as an operator change the password of the VM again, and you reboot the virtual machine will go to the virtual router. You have a password for me? No password. So the VM doesn't change its password because there's no password stored on the VR, only if the VR has a password present. So only in this short period when the password is stored in the VR and the VM has not requested the password yet, the password is stored as plain text inside the VR. But then as soon as the VM downloads the password, it's forgotten. The management server doesn't keep it in its database, nor does the VR then keep it. So there's this short period. But anyway, you want to change the password right away after you got in and started using it. By the way, the microphone for me, it seems like it's a little bit. Okay, cool. But there's Python code again, which of course tells us how this works. This is a part again of the CloudStack data source, and very simple via wget. It downloads from the virtual router address on port 8080. That's where the password server is running. And it does a request for send my password, and that's what it asks the VR. Can you please send me the password? And yeah, they're using wget. It could have been the internal Python request library, but this is how it is right now. Has anybody ever here contributed to the cloud-init driver of cloud? Well, maybe we should give it a bit more love and tender than it's currently receiving, because if I look at the Python code, I'm like, well, there's a few things we can improve here. So maybe to encourage people, contributing to CloudStack is not only actually CloudStack itself, but contributing to this Python file in cloud-init could be something as well. But hey, this is how it works right now. It simply downloads the password, but then it has the password. How does the password then actually get resetted? Does this data source have something magic? Well, no, it really doesn't. So the Python code is that there's the CloudStack password server client, which then fetches a password. Well, it tries to get the password. Well, if there's no password, but if there's a password, it simply sets the cloud-init option, SSH password authentication, to true. It sets a new password. Cloud-init will then actually set that password for the user root. And it says that the password should not expire. And you see, the password itself is simply the variable which we got from this method of downloading the password from the virtual router. So it's merged into the dictionary inside cloud-init, and the data source then simply hands over the dictionary inside CloudStack to cloud-init and tells, well, this is what you need to do. And then the password goes in, it goes via all the same functionality to get this actually done. For example, the first line saying SSH password authentication, that tells cloud-init that it should modify the configuration of the SSH server running, that password authentication should be enabled and also enabled for root. Otherwise, you might still not be able to log in because it's prohibited. So those are kind of things we should do. But CloudStack simply leverages on the default functionality of cloud-init by just providing the right data. So this is what the data source inside CloudStack does. So, fairly simple process, fairly simple Python code doing this work. And SSH keys, as I mentioned, are actually the same. They are presented via the instance metadata to the instance. And, but you have two methods. So you can use the key pair method inside CloudStack, which might be beneficial to you. However, there's still this limitation that only RSA keys are supported in CloudStack at the moment. So if you want to have more fancy key methods, they're not being supported. So using Userdata, you can inject any of your own keys you like into the VM. And then there is the other method called ConfigDrive. Anybody here using ConfigDrive already in CloudStack? I see one hand. Yeah, so that's what I meant, Rohit, with the majority still using probably the network functionality. But let's assume that you have a network where there's no virtual router, a layer 2 only network, a network without DHCP. That's also possible. So, but config drives are simply a virtual CD-ROM being presented to the VM where we store the cloud-init information. So the KVM agent will make sure there's a virtual CD-ROM being attached to the VM, and then the VM or CloudStack actually, cloud-init actually detects the CD-ROM, opens it, and fetches the information from a local drive. So the virtual router is no longer in the process, it's just a virtual CD-ROM. This was actually originally designed for OpenStack, so you'll find a lot of OpenStack references in the code and also in the directory structure. So again, as I said, maybe you have a layer 2 only network without VR, an IPv6 only network. So because remember, cloud-init doesn't work via v6 because there's no DHCP on IPv6 being used. We're using stateless auto configuration for v6. So there's no VR involved for v6. So config drive could be a functionality, or we can do a lot of things, of course, adding IPv6 detection to the data source if we would like. But for now, you could use config drive. And then the directory structure is fairly simple. I got this as well from the OpenStack documentation. It simply has a directory OpenStack, then latest, and then there's a metadata JSON file, a Userdata JSON file, and you can have more data in there which is being served. If you look at the Java code, you'll see that it generates a CD-ROM which is then attached to the VM, and it gets the data. It's fairly simple. I think the label is going to be config-2 for the ISO. Do I dare to do a live demo? Yeah. We should, right? So it's this fairly simple cloud config file I'm going to be pushing. So it's going to be touching a file, a first boot file, going to set the time zone, and I'm going to inject my SSH key into this VM. There we go with the Wi-Fi, which broke away. Let me clear my screen. So I'm going to be deploying a virtual machine. Everybody knows CloudMonkey, I guess. Who doesn't use CloudMonkey? Then maybe I'm showing a tool. I got one. Okay, CloudMonkey, that's the tool you want to use for the API. So I'm going to be deploying a virtual machine. All kinds of fancy stuff. However, the most important part here is that I got the argument Userdata, which then contains base 64 encoded information which you sent. I think we're currently limited to 1 kilobyte. Maybe Simon, looking at you, It's 1 or 8 kilobyte, but you can put a lot of information in 1 kilobyte to be sent just as bootstrapping the VM. So I want to have a virtual machine and then just pray it's going to be booting. So I got my demo 1 VM booting up. And as we, of course, work with v6, and voila, there's the file called first boot. So we simply have a file inside the VM, or I can check the authorized key file, and it contains the authorized key I wanted to have in there. So very simple example of just touching a file and getting an SSH key in there, but I would just want to emphasize the functionality, because right now, if you're using a tool like Terraform, you can inject your SSH key, it boots, then Terraform can go in and do all the magic with the VM, and then Ansible can go in. I think you can even use Ansible Cloud to deploy a VM on CloudStack. So Ansible Cloud prepares the user data, then Ansible can go in, prepare the virtual machine, and then the question is, can you deploy 1,000 VMs? You're like, yeah, sure, 1,000. Okay, fine. That's 1,000 API calls to CloudStack, and that's it. Then I have 1,000 VMs running with my application. But the main thing you want to configure is the cloud config file inside the VM. So etc cloud.cfg, that's the config file where we say DataSource list CloudStack, because it's only going to be a environment which is going to be running on, so CloudStack is the data source. Well, some timeouts. Config, well, do not touch the network. cloud-init can also be used. For example, if you're using a ConfigDrive to also configure the network, we say do not touch the network. Well, then there's a few things. So system info, the default username is root. That means if we do a password reset, we want to reset the password of the user root. You could also set this to Ubuntu if it would be an Ubuntu one, or CentOS, or Alma Linux, whatever. We say root. Well, root is not disabled, and then we have all kinds of modules. So we have a module, bootcmd, grow part. That also means we can grow partitions. We can resize something, or disk setup, or mounts. That means that we can format a drive to ext4 or XFS and have it mounted under a certain location. So this means that if you deploy a VM with a root disk, that's fine. If you then add a few data disks, you can automatically have cloud-init already format and mount the data disks for you. This is very beneficial if you want to deploy a database server on there where the actual contents of the database server should be on a different disk than the root disk. I can go over all the modules, but you get the point. You can do quite a lot of things with this. And again, if you want to learn more about it, go to the documentation of cloud-init and figure out what all kinds of fancy modules are there and the things you can do with it. Yes. Now, then we need to build a template, right? We need to have a template where we can build a template and actually do this. So I can start giving a talk about building a template for CloudStack, or we can just push the stuff to GitHub and you can find it there yourself. So if we go to our GitHub repository, this is just available on GitHub, and this is where we build all our templates. And we push them publicly to GitHub because there is no intellectual property inside those templates of us. It's just in a Linux system with some cloud-init installed, and we use the tool packer.io from HashiCorp to build these templates. We run them in internal GitLab CI/CD, and we simply build the templates. It results into QCOW2 files, and we inject them as templates into CloudStack. And we just need to have a process of updating the template, getting a latest version of Ubuntu 22.04 of the newest Alma Linux. I see we're still lacking Alma Linux 9 in this case, so we need to have one for that. But we simply update the templates, and the templates itself are very minimal, very, very minimal. It's just, let's have a look at the Ubuntu one. It's a few things. It downloads an ISO, and then it starts booting the ISO. And here you see that we actually copy the cloud configuration file from this repository into the VM. So that's what Packer does for us. We copy a few things for Watchdog, from NetPlan. So this is what you need to do with the template, making sure the template plays nicely with CloudStack. And then we have a post-install script which we run to do a few things, and that's it. And then we clean up the VM. So instead of reinventing the wheel, I recommend go to our GitHub repository, download this, and we love to see pull requests if you see something better, because again, there's no mentioning of our company inside these templates. These are just Linux templates which we use to run Linux inside our cloud environment. And maybe we even want to have just a CloudStack repository with templates which work instead of having everybody building this themselves. So, and then just one more file for the, I think it's the generic directory. Yeah. So here you found the same cloud file which we are using inside the VM. You'll find it here in the repository. And then, of course, we always get to the time point, because I got 50 minutes allocated, but you probably have a lot of questions. Yeah, I see 2 hands, so do we have a mic somewhere here? Okay, cool. I see Dan had a question and Lucien had a question.
Hey, you mentioned the limitation of the user data. Can you point to where in the system? Is it in the database of CloudStack, on the VR, or in cloud-init itself?
I think it's yeah, so your question is of course about the limit, how much as a payload you can send. So yes. I think it is actually the column in the database, because we store this data in the SQL database. And there, I think it's simply a varchar which has a limit. However, this is something very important to note. The cloud-init data, or the user data you send, should not contain any sensitive information. Never set any secrets, passwords, other stuff in the user data, or trying to provision a private key with it, because it goes into the database and that remains there forever. So functionality should never contain any secrets. So, but the limitation is the database. Yeah.
Question about ConfigDrive and network management. I saw you say that it works for L2 networks, where we don't normally assign any IPs on the VM, and IPv6 networks. So last I tried, ConfigDrive did not really allow setting IPs on the VM, unless I'm...
No, that's true. So technically ConfigDrive can support it, but the CloudStack doesn't do it at the moment. So what we could do is we could still use a IP allocation, but never send it to a VR, just inject this into ConfigDrive, and then have the VM configure its IP. But that means we need to have an allocator inside CloudStack, which actually does this. So ConfigDrive, cloud-init supported, but we do not have a provisioning process at the moment to make sure that we get this IP information into the VM. But I know that, I think it's DigitalOcean and Vultr, they do this. They inject the network information into the VM via cloud-init, and then you'll see that the IPv4 and IPv6 addresses are statically configured in NetPlan, talking about Ubuntu then, after the VM has been booted. So that would be an additional functionality. Yeah, well, I agree with you. It would be great because it gets away with DHCP, so you no longer need DHCP. So there's a, because I've seen some issues with DHCP in the past. You have leases. Yeah, all that kinds of stuff. So it would be great if we would have the support. And then it's up to the user to decide if I want to use DHCP or if I want to use ConfigDrive for the networking. Yeah.
So Wido, we've got some questions coming in from people watching online. Luridan has asked, is the cloud-init config identical for all Linux operating systems?
Okay, good question. So is the config identical for all Linux operating systems? Well, yes and no. So if I go back to this slide, which I have here for some example data. Now, if I want to install the package called Apache 2, that's only going to be working on a Debian base, so Debian and Ubuntu based distribution. Under Elmo Linux, it's called HTTPD. So you need to have a different package. So, but the user data is generic, or is similar to all cloud environments. If you would take this piece of cloud config, copy it into a DigitalOcean UI and say boot, it will work. So it's the abstraction of the data sources which make sure that cloud-init gets the right information. It's up to you to make sure that the commands you put in here actually work. So the package called Apache 2, if you want to touch a file, that you make sure that the path exists depending on the distribution you're working on.
Brilliant. Next question is from Carthy. Is it possible to use vendor data using cloud-init?
I don't think so at the moment that we support this. Maybe somebody else here in the room knows, but I don't think we're able to support vendor data yet. It's only user data.
Thank you. Next one is from Harry. Does cloud-init get applied on every boot of the VM, or is it something configurable in the cloud-init script itself?
So that depends on how you configure cloud-init, but usually it runs every boot. So it goes to the VR to request the information all the time. But you are not able to update the user data at the moment of a VM. So it's only being set there on initial deployment.
Okay, that's all of the online questions.
Okay.
It's whether anybody else has got any more in the room.
There's one question back in the room. Yeah.
Yeah, so cloud-init kicks in after every boot, right? Is there any way to configure it where it can statically listen and then maybe pick up the data without a reboot? Because like when you have to change the SSH key or reset a password, you always need to reboot, downtime and all of that. Is there any way to configure cloud-init so it doesn't need a reboot?
That's a very good question. I technically, if I go to this VM again, no. I need to learn typing. So cloud-init, you can run it manually. I've never tried it, but you know the thing you ask, you could run cloud-init in, let's say, a systemd timer, where it runs every few minutes, every hour or something, I don't know, in some period. I've never tried it, but it is a possibility to simply run cloud-init and actually have it run and do the stuff. It's now configured to run at boot, but give it a try. I'd like to hear the results.
Thank you.
However, one thing though, CloudStack currently does not support resetting the password of a VM while it's running. So the API call will be rejected, so we'll also need to update CloudStack to make sure you can do this. And the same goes that with updating the user data. Right now, the user data is being pushed towards the VR on startup of the VM. So that means that the whole process of actually getting the data into the VR needs to be updated as well. Yeah, and an issue to get up, indeed. Yeah, so many things to improve. Yeah, but I do agree. It would be very nice if password resets could be done with the VM running, but then you need to have a method. But to actually run cloud-init or trigger cloud-init, but it's up to you as an admin to make sure cloud-init is then configured that way. No more online questions, Giles. Just to check if the quick look, and then oh, there's one more question here from.
When if there is something in the cloud-init that fail, it's continue the next steps or it stops?
No, it continues the next steps.
For example, there is some package that is not exist. It continues the process.
Yeah, it could be that a single module for installing the packet fails, but the other modules will then continue. So your SSH keys will be provisioned, but the script execution might fail or a package installation might fail.
Okay, thank you.
Yeah.
So sort of leading on from that, is there any sort of way of tracking any error codes or anything if anything fails to take conditionals further down?
The log file inside the VM, because CloudStack itself doesn't know what happens inside the VM. So the user data is downloaded by a cloud-init, and that's all it knows. That's all. So how it actually is then being processed inside the VM, we don't know as CloudStack. No.
I could add to that when cloud-init hits an error, then it outputs that error to standard out. So if somehow you can hook a serial console onto the VM and retrieve that text, serve it to the user, like some other platforms do, that's one way of getting some idea of what's going on.
Fair enough, indeed, yeah.
So it saves you logging in into a broken VM, try to parse log files and so on.
Yeah, it can be sometimes a pain in the ass to get this up and running properly. So therefore, I recommend take a look at the templates we've built because we know that they work with CloudStack with cloud-init. This took, I wouldn't say it took years to develop, but it took years of little fine tuning to find the configuration works really nice for us. It might be different in your use case, but indeed on standard output on the console of a booting VM, so if you open the console, you'll see the steps cloud-init is executing if something is failing there.
Thanks, Wido. This is awesome stuff. One thing I will say from our experiences, because cloud-init is not exactly the most intelligent tool in the world, is we try and pass out stuff to Ansible as quickly as possible to avoid running into the errors that Lucian was referring to. The other thing I'll just also point out, based on something you said as well, was that because the base 64 will get logged as well. So it gets put in the database and it's going to get logged. So you do not want to put passwords, as Wido said, unless you want to have a compromised VM. And the other thing too is that I know the people love the idea of being able to hot patch a VM with a new password, but that can also be a security risk because the thing is that no one has access to your VM at the time. So if you suddenly hot push something in there, you could potentially compromise that VM if something else has already been hacked.
Yeah, it would be interesting indeed if you are able to reset the password of a running VM, you get API access and you can just reset the passwords of all the VMs at once and then actually get into the VM. So potential security risk there indeed. But your other comment of saying handing stuff over to Ansible as quickly as possible, I do agree. So I think most of the people simply push a few SSH keys, they log into the VM with Ansible and then have Ansible do the rest. However, it is quite powerful what you can do with cloud-init, so figure out what works for your use case. Well, if that was it, no more online questions and no more questions here, then thank you for listening to my talk.
Thank you, Wido.